Welcome to the great conversation where ideas matter. Ideas can not only shape markets, but that it can change the world as well. And those of you who know me in this community know I'm all about changing the world. I knew a gentleman by the name of Rob Tiffany way back in the late 90s when we were dealing with clicks. And clicks were the business model. And we were trying to put together an ecosystem that would take advantage of those clicks. And I've been stalking him ever since. Right now, he's the vice president, head of IoT strategy at Ericsson, but he's lived through the maturation of these technologies that are going to define our new world for the last 20 years. Welcome to the great conversation, Rob Tiffany.
Hey, thanks for having me, Ron. It's good to be here.
It really is. We've been just catching up for the last few minutes, but this is going to be an unscripted conversation as always. And I challenge Rob, how do we simplify the complexity of this world that we're living in? And I suggested we start walking through a data ladder. And then I found myself getting lost in the data ladder too, because there's no visual representation of it. But Rob, how would you take a business executive who maybe is developing a device or is developing an application, and they're trying to figure out where they place their bets? We've got these business models that all hinge on the as a service model from Azure and Google and Amazon. We have ecosystems that are developing around those models. How do we simplify all this? Where are we today, and where's this thing going?
Wow, it's a messy world out there, isn't it?
It is.
Gosh. And yeah, there is that tendency to just ride that wave, and there's nothing wrong with riding waves, because sometimes that can be the best thing you can do. But when you talk about the cloud thing, devices, that's such an interesting space in general to be a device maker. If you're thinking about, especially, you're probably not making handsets anymore because that's pretty locked up. But if you're making IoT devices or other things like that and sensors, of course, most VCs will tell you to please stop what you're doing right now and back away from the hardware. And there's a lot of validation to that. We need that hardware to make this stuff work, especially this whole Internet of Things mega trend that, we're trying to get so much extra value from the world that's around us, where things can start talking to us that previously we were having to go discover ourselves. So we need those devices, but people in the bigger space will realize that we need those devices to be as cheap as possible. The only reason we have this Internet of Things megatrend is because we had a perfect storm of lower cost devices, near ubiquitous connectivity, wired or wireless or otherwise. A lot of the serverish stuff looks like middleware. Storage costs are going to zero, especially particularly in the cloud. Analytics that used to cost tens of millions of dollars that only big companies or governments could afford. Now I can just go to apache.org and download all that stuff for free. I still have to know how to work with it, obviously. And then that leaves applications. Is it a web app, and native, an iPhone app or whatever, those kind of things, or desktop. And so that's kind of that world that we live in now. And so that perfect storm brought all this stuff to life. I hate to overuse the word democratization of something, but it kind of happened that way. And so it's in the hands of a lot of people. And it also opens up new business model opportunities. Of course, in the past, you always had these super transactional kind of things. I buy it and it's done, or these weird server CPU model type things. And now you have all these as a service models to get into to make more quickly. So if I'm a device maker, I've got to do things as cheap as possible and at scale. People need my devices, but that's a tough business to be in. And so you're probably doing it in Shenzhen. If you're doing the data collection and storage and analyzing it, you'll be inclined to do it with one of the cloud players. And of course, they've all built a lot of these PaaS layer technologies, platform as service technologies for IoT and collecting data and doing analytics. In my experience, though, there's a whole lot of customers that are worried about cloud lock-in or vendor lock-in. We've all heard that. And it's real or it's imagined, depending on who you are. But I've certainly lived through that and realized the value in building something that's portable, that can run across any cloud or run on-prem on bare metal or VMware or wherever you need it. And this goes back to sales. Software engineers would hate it when I'd tell them, I need you to think like a salesman while you're building this software. Are you making this easier to sell? Are you making something that you think is really awesome, but it's going to be really hard to sell? Because we all know lots of startups that died on the vine with great technology sitting on the shelf. And so the ability to build something where you can say yes to those, when the customer is asking you, will it run here? Can I do this? It's great to be able to say, yes, absolutely. Yeah, it's going to do that. This plays into security a lot. While everybody, and I experienced this at Microsoft, we thought it was good enough to have Azure regions in Europe and other places, and that all of Europe would be fine. And then what did we discover? Well, in Germany, that's not good enough. The level of security paranoia is so much higher that, if you go to a heavy manufacturing country like Germany or Japan, you still have folks that say, it's not enough to send my data to somewhere else in the EU, like the Netherlands. It can't leave Germany. Or I run into people that says the data doesn't leave my factory. So I remember the first in-country Azure cloud region we had to build was in Germany, just for that reason. We did this Black Forest project. When I was at Hitachi building this Lumada industrial IoT platform, I'm spending all my time in Japan, in Japanese factories. And guess what? All those factory owners of different players, they're all untrusting of each other. And the notion that you're going to send all their data to the cloud was insanity, actually, which may seem strange to people listening to this. And now sometimes it's common sense. Like if you're building a nuclear reactor, that's a great way to get fired, is trying to connect that to the internet and send that data off. And so there's things you just didn't do. And so yeah, making decisions. So sometimes you make decisions, like if you're designing some big system or whatever, I can get to market faster using cloud stuff, past stuff to get me to market quickly. But I can take a little bit longer and make it portable and make it more flexible for my sales model and for dealing with security and governance and sovereignty and stuff like that, which turns out to be a big deal still today. I can't tell you how many people said, hey, let's just use those cool AWS Lambda functions and we'll get this product out the door in no time. And they're probably right, but we would have been stuck. There's this notion of entanglement that I always think about. The cloud players want you to become entangled with them. They have all these PaaS layer offerings that they want you to take advantage of with their APIs. I liken that to iTunes and the iPhone. And because I spent a lot of time in my life in the mobile space, with Windows Mobile and Windows Phone and building that stuff. And what I saw was people would have all their music in iTunes and they loved it and it was great. And maybe a Windows Phone came out, or maybe a new Android device came out, and the customer would say, gosh, I sure want to switch to that. But the switching costs were too high because all their music and their whole world, their ecosystem was back in iTunes on that Apple device, on that iPhone. And so they wouldn't switch. And this same thing applies to the hyperscale cloud players. The minute you build something that taps into those PaaS layer environments, you will become entangled with them and you'll find it difficult or impossible to leave. And so when we're in this world, if I'm building a product or whatever, I'm trying to be successful in the market, it's stuff I have to think about because I may turn off some potential customers. Some customers won't care, but some want that flexibility. In the IoT space, have you heard about these orphaned devices or the internet? I'm not even going to say the word, but anyway, where especially I've seen this in the consumer space. You've seen all these devices that are made and they're mostly consumer, and you go buy them and they're way more expensive than the normal non-connected version, but you spend a bunch of money and it's connected to some backend thing, a cloud. And then for whatever reason, it stops working because the backend system degraded or somebody went out of business here. And now you're left with this device that's useless now to you. This happens a lot. It's like a weekly deal I read stuff about. your ability to disconnect from something that's degrading and reconnect to something that's working is probably kind of valuable. And so back to, if I take this to IT people, pragmatic folks working, managing data centers or clouds. That's why you're seeing this multi-cloud thing. That's why you're seeing adoption of these cloud native concepts like Kubernetes and other things and containers that can run anywhere. And so that's the choices we made with Lumada. We did the container-based approach and orchestrating that so that it could run anywhere, so that we never found ourselves stuck. We never took dependencies on things that we couldn't break out of easily. And we were able to say, sure, we built hardware too. If you want to run the whole thing, and we built stuff that could run on bullet trains if it needed to, or right on a factory floor. Economics always trumps everything in technology and products and stuff like that. I certainly remember times, early days in Azure IoT, talking to friends that manufacture really large things nearby us in the Seattle area in giant factories. And you would talk to them about this great machine learning technology and streaming analytics in the cloud and how awesome it is. And they'd say something like, wow, that's awesome. Show me the version that runs right here on my factory floor, right next to this giant machine that cost me tens of millions of dollars that makes these other machines that cost even more, because I'm not going to send all terabytes of data per hour over expensive bandwidth to some distant cloud to have it munch on data for a while and pop out an answer to my question, or is this thing about to fail or whatever. I need it right here with low latency, millisecond latency right here on my network close to where it's happening. These kind of conversations early on kind of gave rise to what people called fog computing and edge computing. And so it's not like edge was some genius idea that someone came up with. We should disrupt the whole cloud industry. No, it's pragmatic stuff. These are just real people with real problems. It was totally pragmatic. It costs a lot of money to send data over bandwidth to some distant place, and it takes long. There's latency, and it's doing something, as opposed to something that's right there on your LAN or whatever, right nearby. And so it was just simple pragmatic things like that gave rise to what we call edge computing. I need to know the answers to my questions right now in milliseconds, not seconds, or what if my connectivity goes down or whatever, things like that. Moore's law helps you. We're able to do more computing power closer to where, the edge is all about being as close to the source of the data, the machine or whatever it happens to be, as possible. And so I am close to it. I can get it quickly. And what originally started off was with maybe basic filtering to filter out a bunch of stuff before it went to the cloud, led to complex event processing, and then now we're able to push down machine learning models and do that at the edge as well. But don't think this is all some magic high-tech stuff. It's still computers, and it's still just running code and stuff like that. And it's the same stuff you're doing in some cloud or your data center on big servers. It's just that smaller machines are getting powerful too, and you can make stuff like that happen anywhere. So anyway,
so here's what I've just heard. I'm going to start with a basic premise, and I'm going to sound like Jeff Bezos, I think. I'm going to start with a basic premise. Since we cannot let complexity get in the way of the buying decision, because you start with nothing happens without a sale. Nothing happens without a sale. So the lower the cost, we take away that friction in the buying process. The higher the availability, always on, at my fingertips, the quicker I can get to my outcome and the quality of that outcome. Those things drive buying decisions.
Absolutely.
Now let's start talking technology. Mr. Customer, if you're saying you're locked into the Azure ecosystem or the AWS ecosystem, right? That could be, in my investor strategic plan, a good thing. Like you said, I can ride that wave all day long. There's plenty of market in that wave.
Yeah.
But if you want to not be locked in, if you want to be available to all users who may not want that particular cloud provider, then you're going to have to do something different. Now, when we start talking containers and we start talking about AI at the edge, not dependent on a massive cloud computing scenario, is that real right now? Is AI at the edge real? And what are the constraints of that approach in giving me high availability, quick outcomes, quality outcomes right at the edge, even if it's what did you call it the other day? Another silo. It could be just another silo. So now we're still into the integration problem of that data and that outcome. But go ahead.
Yeah. Well, AI is a really broad term. It means a lot of different things to a lot of people. Usually people are just talking about machine learning when they say AI, but it could be a lot of cognitive things. Like let's get a totally different example that makes sense at doing something at the edge. Under that giant umbrella of AI, you could have things like computer vision, that I'm recognizing something. And so we have a world where people have cameras everywhere. And I'm not just talking about CCTV, looking at faces and counting people, which that's a thing. But it also could be doing simple things in IoT. Like, I'm a big fan of doing really low-hanging fruit things in IoT. And so one of those things is, if I'm in a factory, you have a whole lot of people who spend their day with a clipboard walking around looking at gauges and taking readings, and they write it down on a clipboard, and then they walk back. Or sometimes they get in a pickup truck and they go off and look at oil tanks. Sometimes they get on airplanes to do this. But they go find out something, as people do, and they look at something and they write it down, and then they come back to the office and they type it into some back-end system, SAP, whatever. Well, you could imagine a computer vision model under that AI umbrella, where your camera is now looking at that gauge, and your computer vision knows what it means when that needle says 60 PSI. And so it can translate what it's seeing to a digital value and then update your database, your backend system accordingly. Whereas before, a person was looking at the gauge and going, oh, that's 60 PSI, and I'm going to write that in. And that's a stupid, simple example. But there's also the example, again, where you're counting people, or you're doing the video surveillance stuff like you might be seeing in some countries. There's so much data. Video is the biggest thing in the world as far as eating up bandwidth, right? And so you probably don't want to have to send all that to the cloud. So if your AI, your people counting, computer vision, whatever you're looking for, if you can have that running locally, so if your camera also has compute and storage and RAM and networking, that kind of stuff, enough so much that you can run that there, that's great. I'm going to weed out lots of stuff that I don't care about and only capture the stuff that matters. The other thing that's helping doing AI-ish stuff at the edge is the advent of finding out that GPUs were good for things besides video games. And so, NVIDIA has certainly made hay from that, and gosh, you can imagine companies where that's all they were about, was giving you fast graphics cards. And then lo and behold, a lot of this AI stuff takes advantage of these GPUs and it accelerates it dramatically. And so you are seeing a lot of edge devices that have all these GPUs in it, and that accelerates their ability to make calculations way faster than your standard x86 or RISC chip, right? And so that stuff's making it real. So it's software, it's being able to push that stuff down there. You have to train the software. There's always been this notion, I say always, in the last several years, that if I'm going to do something like that at the edge, I may still train that model in the cloud or on a big server where I have more horsepower. And that still happens today. And then I will push that model down, maybe in a container running on that edge device. And when I say edge device, I'm just talking about a tiny computer. Right. It's not rocket science. But over time, there's open source things. There's something called TinyML, and there's other things that people are doing where they're actually training the model right there at the edge. I know startups that are doing amazing things where they don't have any human supervision ever at all. It's like turn on the fire hose of data, and it figures out the data schema and what it's looking at on the fly over time. It builds digital twins on the fly. And then it starts creating machine learning models and training them on the fly at the edge. There's amazing stuff going on out there in the world, which is pretty cool. You just kind of throw all these things out there and it just figures out how to optimize streetlights, and stoplights and traffic flow on the fly, as opposed to a command and control deal where a lot of people are having to manually program things to make it work. So it's certainly getting real. I know it seems esoteric to a lot of folks, but it's definitely making a lot of progress.
We're right now having a conversation in the leadership series in the Great Conversation. We also have a great conversation in security. For you security members, I'm going to throw this question at Rob, even though he isn't necessarily in the security industry, but in the physical security industry, we have video surveillance cameras. And then we have video management software that manages the output from those cameras, right?
Right.
And then we are starting to see analytics at the edge, as well as external analytics software routine running against those video images, that video surveillance aggregation. And it's interesting because you see video everywhere.
Yeah.
But you don't see audio along with it. It always drives me crazy,
That's a good point.
to see video without audio. And you can give all sorts of reasons. You and I both know, I love excuses are like rear ends. Everyone's got one. There's all sorts of reasons not to have audio. And one of them is privacy. Oh, but it's okay to be filming at all times.
Right.
So we have some laws and some regulations we're going to have to get through. But the reason I'm bringing up audio is we'll call it old technology called intercom that now has to climb up the ladder and become more intelligent.
Yeah.
Right? It's got to be always on. It's got to sooner or later be always on, just like video. And it's got to have intelligence at the edge. So if I was, and we have a number of vendors in the physical security ecosystem would probably be listening to this, if I was a vendor in that intelligent communication space that is just emerging, what advice would you have as a technology architect for them? I think you've already given it, and that is your hardware is going to get cheaper and cheaper.
It is. And so obviously you talk about audio and you've got me thinking about Alexa and Siri and Hey Google and all these other things that are listening all the time. If you go back in time, geeky kids, there's something in databases that goes way back. It's called a soundex query. And this is how, because this evolution of knowing what they're hearing goes back way further than Siri and things like that. It goes back to Shazam and things before that, where it's like, can you recognize this song? Well, once we started digitizing music a long time ago, when we invented CD-ROMs, that's how we got to where we are today. It's been an evolution, but we digitized music, and then there were soundex queries that you could run in a database, just like you would do a select query to get data back. And you could say, hey, I'm giving you this little passage of music. Do you recognize that? Oh yeah, that's from whatever song. That starts the evolution of how we got to things like, hey Siri, hey Google, hey Alexa, that kind of thing. That's a Pandora's box, and the genie is already out, and the horses are certainly out of the barn.
Well, I remember, I don't know if he was a friend of yours, but he went to my church and he was heading up the Alexa group, and he told me they were actually surprised how quickly Alexa was adopted, where people would put it in their bedroom. He goes, we never expected to have that massive proliferation. Even us didn't expect that. We thought it would take a number of years, and it didn't. And so it's in the consumer space. It's always listening. It's making decisions on that data.
Right.
And so here's corporate America lagging backwards from that consumer space. And as you start talking, and the reason I brought it up is back to what we're trying to do is make decisions quicker, cheaper, faster, with higher degree of quality. And you can't do that without both your eyes and your ears working on the floor.
Yeah. And so, as you can imagine, all that technology started off with, we've got tens of thousands of servers in a cloud that are listening, and they're making the decisions, and then they're going to give you the answer back on your phone, for instance, when Siri came out and things like that. over time, compute power has grown, and that crazy GPU thing has grown so much, and they're putting that on smartphones, and they put it on your little Echo and lots of other places. There's the notion of, I need my phone to be able to answer my audio question without talking to some server. And so it downloads a whole lot of stuff because the storage got really cheap, right? And so you've got enough stuff on your smartphone or these designated devices to answer a lot of those questions locally without having to go back to a server and do it. It's interesting what you said about business lagging behind consumer. That's pretty normal, but it's weird. A CISO might go, are we really lagging behind the consumer by not putting this all over my company? Or are we smart and not opening Pandora's box? Because you've heard lots of stories when you found out that it turns out there were a whole lot of people listening on those, hey Siri, hey Alexa, hey whatever things. That came out in the last several years where it was people, and they're actually trying to improve the models ultimately, but a whole lot of people were listening, and a whole lot of people heard a lot of stuff they probably shouldn't have heard. And that came out in the news a lot. And a lot of people went, wow, how stupid was I to trust this thing? So I don't know how that's going to play out,
Yeah, well said. Well said. This has been a great conversation with Rob Tiffany, and I'm sure we're going to have many more fireside chats in the future. One of those things I want to talk to Rob about is his passion for changing the world, not just the business world, but changing the world. But we'll leave that to a future conversation. Rob, would you suggest anyone else we should be having a conversation with?
Wow.
That you'd want to hear from for 15 to 20 minutes.
Wow. Someone else that I'd want to hear from. I know different analysts in that community who know a lot about different technologies, and they're people I know. Leonard Lee is one that I know. He's an analyst. He's like an ex-Gartner guy who runs a firm. There's a few of them that are pretty plugged in.
I noticed you responded to my my last audio cast with a local Cascadia investment firm here in Seattle who's launched a fourth industrial revolution category in their practice. That was interesting, wasn't it?
Yeah, it is. Well, that's a big mega trend. And that's a wave that other waves are riding, whether if you think IoT is a wave that maybe is sputtering, but this industry 4.0 thing that started in Germany with manufacturing and has spread, that's a bigger mega trend that is driving a lot of use cases that's going to have a ripple effect. I'll give you some simple example. If the internet came out, e-commerce came out, I could buy a t-shirt and I could say, I want the t-shirt to be red and I want it to say this on it, and I can customize it infinitely. Well, you've got folks who say, I want to do that with cars. But what did we find out? The only way we can do cars at scale was that whole assembly line model, and all the cars need to be roughly the same in order to do that at scale.
You can have any color as long as it's black, Rob.
Exactly. Well, Industry 4.0, one of the big use cases is this thing called mass customization. And again, everybody's adopting Industry 4.0, but it started in Germany with the government and manufacturers. It started as a manufacturing thing. How do we do mass customization of machines, big things like cars? What it means is you're going to be breaking away from assembly lines that don't change for a year or until they're retooled. You're going to have different stations where things to be moving to. And so how does that change technology? It means maybe you're using Ethernet because things never move, and that gives you high-speed stuff. Well, now they're going to need high-speed wireless because they're going to move around. So there's a lot of talk of this notion of private 5G, and governments in Germany and America and some other places are opening up spectrum that normally you would only auction off to mobile operators. They're having spectrum now where private enterprises can get spectrum, and they can do private lockdown 5G in a factory, a distribution center, a warehouse, whatever, or a corporate campus or in a skyscraper. Think about where you realize I got to go to Wi-Fi or something wireless because I'm moving around and I'm agile now. And so there's certainly a hard look being taken at things like private 5G to facilitate that. And then IoT, cyber physical systems, advanced analytics is riding that wave. IoT goes from, and things like digital twins turned out to be at the heart of this stuff, of modeling machines and processes and parent-child relationships between this machine and a group of machines working together. I mean, it gets crazy complex.
Right.
But a lot of these things that we've been working with, sometimes in the consumer space and other things, are an imperative to get to where we need to go with this industry 4.0 stuff. So it's pretty cool.
It's fascinating when you go from the software development world to what I'm going to use my own term for it. You were talking about the assembly line. We in the software development world, we've been talking about widgets that'll help us do application integration for some time, and rapid application development for that reason.
Yeah.
And in a similar term, in an analogy, is taking that same principle for moving the components of manufacturing around. If you think about it, we're gonna widgetize it, move it around. We're going to simulate it on the back end, the digital twin, so we can see it works. And then we're going to move it quickly into production, but they will be able to be moving to the market demand, whatever the market demand is.
The things that we think of as groups, grouping things together. A lot of stuff like, my pet thing is I've driven a lot of the digital twin technology over the years. And so there's this, what started off as, hey, it's just a simple digital representation of a physical thing, right? And then you went to the next level. Well, maybe you have advanced subsystems in a machine and they deserve their own digital twin. And so maybe there's a parent-child relationship. Like the engine of a car is complex and it's got a child relationship to the whole car, which is the parent digital twin. But then it's part of a bigger ecosystem. And instead of just, so like if I'm taking industrial robots along assembly line, there's a twin of each robot. In the past, you'd say when they belong to a group and the group's called assembly line. Well, but the idea of saying, well, it shouldn't be that simple. The group should be a digital twin itself with its own properties and analytics. And so the assembly line is a twin, and how all their constituents play together and interact, the ripple effects of failures and anomalies, and then how, and then being able to change them a lot. And so groups are being morphed, and whoever's playing on this team this week might be playing on another team the next week, because what used to be, I retool my factory every year when a new model car comes out. Now I'm retooling every week because everything is so custom.
And what I love about this, Rob, is, and we're not going to get into it right here, but there are people and management structures and business models that are looking at this and saying we have to rethink resource allocations, how people actually report to people in a assembly line, right? Versus right? And be able to move them around virtually when we need to. Yes.
Boy, you don't want me to talk about some bizarre, I'm also a science fiction writer. And so be very afraid, because I've also written stuff where HR is adopting the notion of digital twins to represent employees, and APIs represent the interaction between departments and employees.
So time out, because we're going to have another great conversation on that right there. I want to geek out on that all day long. Are there any books you'd recommend to the community right now that you're reading or want to read? Anything that you think we should put on the resource page saying, hey, Tiffany says you might want to take a look at this?
I'm currently reading a book. A friend of mine, she was my boss at Ericsson. She wrote a book. Gosh, I'm going to misquote what it is. It's kind of like your move fast, break shit, burn out. Anyway, you know what? Gosh, I wish I had.
You know what? You'll think of it. You'll send me an email, because I don't think it's move fast, eat shit or anything like that. I don't think that's the title.
You might be surprised.
Yeah, no, I'm laughing. If anyone could see me on video, I'm laughing right now because I've seen a lot of books like that. don't F this up kind of stuff.
Yeah.
On the title, right? Yeah, no, I get it. I get it. This has been a great conversation with Rob Tiffany. We will revisit with him in the future. We'll geek out on nonfiction and also stay right on top of these new mega trends that are developing real time that'll change our culture, change our business, and change our world. Thanks, Rob.
Thanks for having me, Ron. It's been great.